Welcome to The Explainer. Today, we're going to decode the secret language of the heart's electricity. We're going to peel back the layers of the electrocardiogram. You know it is the ECG, to really understand how it gives doctors such a clear picture of what's happening inside our most vital organ. Okay, so here's our game plan. We're going to start with the basic setup. Then we'll explore the two main ways we take measurements, the standard and the augmented leads. After that, we'll see how they play together. And finally, we'll get into why this whole dual system is so incredibly powerful for making a diagnosis. So before we get into all the nitty-gritty details, let's just tackle the big question right here. You've seen it, right? All those stickers and wires. It looks super complicated, but it's actually a really elegant system designed to do one thing: capture the heart's electrical signals from a bunch of different angles. It's all about perspective. All right, let's kick things off with our first section, the basic setup. Because, to get a useful reading of the heart's electricity, you have to start with a really precise and standardized groundwork. Everything that comes after this depends on getting this part exactly right. It all starts right here, with these electrodes placed in very specific spots. Red on the right arm, yellow on the left, and green on the left leg. And that black electrode on the right leg, that one's just the ground. It helps stabilize the signal, keeps it clean. This consistent placement, that's the crucial first step to getting a reading you can actually trust. Next up is a step that is absolutely critical: calibration. See, before any reading starts, the machine is standardized. This means a 1 millivolt signal will always produce a 10 millimeter spike on the printout. This makes sure that an ECG from a hospital in one city can be accurately read anywhere else in the world. It's like creating a universal language for heart health. Okay, so with that foundation in place, we can now dive into the first type of measurement the machine takes, the standard leads. A good way to think about these is that they provide the panoramic picture, like a wide-angle lens for looking at the heart's overall electrical activity. Now, these leads are called two-pole or bipolar, and what that means is they're measuring the electrical difference between two active points on the body. Imagine it like having two microphones recording the same sound from different spots. Because they're both active, they can sometimes kind of partially cancel each other out, which can give a slightly less powerful signal. And we have three of them. Lead I1 looks across the top of the heart from the right arm over to the left arm. Lead I2 gives us a diagonal view from the right arm down to the left leg. And lead I3 looks at another diagonal angle from the left arm down to the left leg. Each one is a unique vantage point. So, the key takeaway here is that these three leads combine to give us this broad, panoramic overview of the heart's electrical field. Lead I, for example, is great for seeing what's happening in the left ventricle, while lead 3 gives us a better peek at the right ventricle. It's the big picture. But a panoramic view isn't always going to be enough to spot the finer details, and that's exactly where our next set of tools comes in, the augmented leads. If the standard leads are our wide-angle lens, then these are the zoom. So, unlike the standard leads, these are single pole. They use just one active electrode and measure its signal against a central, neutral reference point that's created by the other electrodes. And here's the brilliant part of this design. It actually increases or augments the signal. This gives us a much clearer and more detailed recording. And their function is cleverly hidden right there in the name. The A stands for augmented, V for voltage, and that final letter, well, that tells you the location of the active electrode. R for the right arm, L for the left arm, and F for the left foot. Pretty neat, huh? Now, it's really important to get this. These augmented leads don't work alone. They have an auxiliary function. Their entire job is to clarify, to confirm, and to strengthen what the standard leads are already showing us. They're the support team. So how do these two systems, the panoramic and the close-up, actually work together? Let's put them side by side and see how they really complement each other to build a much more complete story. This comparison lays it all out pretty clearly. You've got the standard leads, which are bipolar and give us that primary panoramic view. Then you've got the augmented leads. They're single pole, and they serve that auxiliary role by giving us an enhanced, very specific picture. One provides the main story, the other provides the crucial details. In fact, this relationship is super direct. The AVL lead on the left arm gives you pretty much the same view as standard lead I. And the AVF lead on the left foot, it basically duplicates the view of standard lead 3. Now, this isn't redundant, it's a brilliant built-in cross-check. It's a way to see the same thing from two different technical perspectives to make absolutely sure you're getting it right.
But, of course, there's always an exception to the rule, right? In this story, it's the AVR lead. Since it's on the right arm, the heart's electrical current is generally flowing away from it. So on the ECG printout, all the waves for AVR show up inverted or negative. This isn't a mistake. It's a critical piece of information that confirms the leads were put on correctly and gives us yet another diagnostic clue.
Okay, so we have these two sets of leads, one for a wide view, one for a close-up. And a lot of the time, they're looking at the same part of the heart. So why? Why does all this matter? Well, that brings us to our final, and honestly, the most important point, the power of confirmation. The entire system is built on this one simple, powerful rule. A clinician never relies on just one view. Any finding from the standard leads, that panoramic picture, has to be checked against the corresponding augmented lead, the close-up view. It's the golden rule. So let's say a doctor sees signs of a heart attack on standard lead I, which looks at the left side of the heart. The very next thing they'll do is check the AVL lead, which is also looking at that same area. Just like our source material says, if that information is the same, if it's confirmed, if it's duplicated, then that doctor has a much, much higher degree of confidence in their diagnosis. It's all about building certainty. So here's the crucial point to take away from all this. An ECG isn't just a collection of different data points. It is a beautifully designed system of checks and balances, where panoramic views are verified by close-ups. And that is what gives clinicians the confidence they need to accurately locate problems and make those critical, life-saving decisions. And that really leaves us with a final thought, doesn't it? This principle of confirmation, of using two different methods to verify the same piece of information, is just incredibly powerful. It makes you wonder, where else in our world is this principle of redundant checks absolutely essential